Today we're going to be doing an AP-style question on position, velocity, and acceleration. The question states, for time 0 through t through 6, a particle is moving along the x-axis. The particle's position, x of t, is not explicitly given. The velocity of the particle is given by v of t equals 2 sine of e to the t over 4 plus 1. The acceleration of the particle is given by a of t equals 1 half e to the t over 4 cosine of e to the t over 4, and x of 0 equals 2. Part A asks, is the speed of the particle increasing or decreasing at time t equals 5.5? Give a reason for your answer.
So, to do this, quick lesson on velocity and acceleration. Sahas is going to be velocity, and I'm going to be the acceleration. If velocity is pointing in one direction, and the acceleration vector is pointing in the opposite direction, then when the velocity is coming, the acceleration is pushing it, and it's slowing down. However, when the velocity vector and the acceleration vector are pointing in the same direction, then it makes the velocity speed up. So keeping that in mind, let's do part A.
So part A asks, is the speed of the particle increasing or decreasing at time t equals 5.5? Give a reason for your answer. So judging from the example that me and Sam showed, we need to know that we need to know the sine vector of v as well as the sine vector of a. When we plug in 5.5 to the equation, v of t equals 2 sine of e to the t over 4 plus 1, we get a negative sign. When we do the same thing with the equation we got for a, plugging in 5.5, you also get a negative sign. Being that they both have negative sign vectors and they are the same sign vectors, the particle speed will be increasing at time t equals 5.5.
So for part B, it asks to find the average velocity of the particle for the time period from 0 to 6. We have this equation, 1 over b minus a, integral from b to a, of f of x, that gives us the average value of f of x on the integral from b to a. So, using that equation, we're going to use 6 to 0 of v of t, and we get an answer of approximately 1.949, plugging this into your calculator. So that is the average velocity of the particle for the time period from 0 to 6. So part C asks to find the total distance traveled by the particle from time 0 to 6. We know that the absolute value of displacement is the total distance, and we know that the area under a curve, or integral, of a velocity curve is equal to displacement. So if we take the absolute value of that, this displacement becomes the total distance traveled. So we're just going to take the integral from the boundaries they give, 0 to 6, of the velocity function, which is 2 sine of e to the t over 4 plus 1. And we're going to take the absolute value of that. Typing that into your calculator, you should get approximately 12.573 meters as the total distance traveled from time 0 to 6. For part D, it says, for 0 to 6, the particle changes direction exactly once. Find the position of the particle at that time. So to find what time the particle changes direction, we need to find when the velocity equals 0. Because the only way the velocity changes direction is when it changes signs. And to change signs, it has to cross 0, go from positive to negative through 0. So we set the velocity function equal to 0. And solve for t. Doing that, with algebra in your calculator, you should be able to get t is equal to approximately 5.1955223 seconds. Now, we need the position at that time. So x of 5.195, which would equal, we know that at time 0, the position is 2, so we need to start with 2, plus the area under the curve, or displacement, from 0 to 5.1955223 of the velocity function. Plugging this into your calculator, substituting the actual function, in for v of t, you should get it to be approximately 14.134 meters for the position at time 5.19 when the particle changes directions.
Who's the best math teachers around?
Obviously Sahas and Sam.